Or okay. Okay. When this is, you can see from this equation A, okay, what happened? This part becomes zero because m1 equals m2, m1 minus m2 is zero, right? So then this part is this is equal m 2m and 2m equal. Then the v1 equals u. v1 equals u. And from the equation B, similarly you can write as v2 equals this part becomes zero. Over here it's like mistakes, right? This is 2m1 minus m1 m2 minus m. The equation should be like that, right? So then this part becomes zero, and then this is equal to 1. The equation make it correct. So the m2 m1 here, and it's m2 and minus m1. Miko karan mana lagi? Terus try kalau bani pa dikan tanda bola ni ke? Miki minimum tadi dia kan dona mi ini result itu bukan begini. If two equal masses collide to each other, right? You heard on collision. Then you need to keep in mind what happened. What happened? This result you can say the m1 mass has the velocity v1 after the collision, right? So the v1 becomes velocity of the second. If two masses collide to each other, what's happened? Their velocities are exchanged. Right? If two masses collide, elastically collide, so their velocities are exchanged. This one has the velocity v1, and then second body has after the collision, second body has that velocity, and second body's velocity goes to the first. Right? The velocities are exchanged. Yeah. After that, you can write hence when two bodies of equal masses, and hence two bodies of equal masses, collide elastically. Into hence two bodies of equal masses collide elastically. Their velocities are exchanged. Right. Yeah. Velocities are exchanged after the collision. The velocities are given after the collision. The collision. Right. To keep in mind, see for MCQ type question, two masses, equal masses they collide. Let's say the one is moving with the velocity 5 meters per second, and other also same mass moving with the velocity 10 meters per second. So then after the collision, the second body moving with the 5 meters per second, and first body moving with the 10 meters per second velocity exchange. Okay, then I'll erase this one, right? The first question. Then second one. Then let's see its masses are equal, right? If m1 equals m2, that's equals 1, and u2 is 0. The second body is stationary. And then you can equal mass. Then let's what's happen. So then from this equation v1 equals to the u2, right? It's 0. And the v2 equals u1. So stationary body moving with the velocity that's the first body is moving, right? And then the first body will stop. That's also the same thing happens. The velocities are exchanged, right? Exchange means this has the velocity 0. 0 goes to the moving body, and the initial velocity goes to the stationary body. Then after the collision, they move in like. So no need to explain more. You can get this as a. You have to keep the mind in. If your body is aligned, stationary body having the same masses. So what happens? The stationary body will moving with the body which is moving initially, and the first body, the moving body, will be stopped. Okay, so that's how. Otherwise, then the third special case, right there, very special case. And here we consider that one body has the very larger mass than the other. Right, this light body collide with the massive stationary body. You can write third case, right? When a light body, collides with massive stationary body. Light body collides with the massive stationary body. So all the cases we consider this last condition. Here then we will see this massive body next to the smaller one is the M1 is the lighter body, right? And then you can see that M1 is very, very small than M2. It's the case of writing here. Okay. You can consider like this. So then M1 plus M2 approximately equals to M2. This M1 is negligible. And M1 minus M2, that's also minus M2. So plus or minus, this is equal to M2. Here we might M2 minus M1 plus or minus M1, that's approximately M2 because M1 is negligible. And if M1 divided by M2, that's approximately 0. Because this M1 is very small. So if a smaller one divided by the larger body, that is 1 kilogram divided by 1000, it is 0.0001. There is negligible. Right? So then using this equation, you can write as V1 equals. We can consider this M1 and this is approximately M2, and this is M1 minus M2, this is minus M2, right? So then M2 cancel, this will be minus V1. And V2 we can because this one will be 1. So sorry, M2 divided by M2 here. That's 2 units, right? Correct? This M2 is this. Yeah, it's minus 1. And here I stationary body, this one is 0, right? This is the stationary body. So U2 is 0. Here U2 is 0. So then this part will not be, this part also becomes 0. And in the second equation, you can have V2. M1 is smaller, this is very large at the bottom. So then this will be approximately 0. And here, very large, massive. The ball is not moving. The ball only the rebound. So that's why it's minus 1. So ball will lighter body rebound with the same velocity to the other direction. That's minus 1. The stationary body remains as stationary. Or after if I am much faster, you tell me, then I will solve it. Right. Then we can really hence when a light body collides with the massive stationary body, collides with the massive stationary body, light is the massive stationary body, The light body rebounds after the collision with an equal speed. Light body rebounds. Light body rebounds after the collision with an equal speed. With an equal speed. While the massive body remains at rest. While the massive body remains at rest. The body remains at rest. Then the other mechanical. If M1 is very much larger, M2 M1 is very larger than M2 is stationary, right? So when you are very bigger body, more. And here M2 is very smaller, right? So it is in station. How we like let's try in tomorrow. We have the basketball or netball and a tennis ball. You can check. Tennis ball is smaller one. Another one, yeah, bigger means it's could be weight is very large. Big mass should be large. You can the fourth case when a massive body. Fourth case when a massive body collides with a light stationary body. A massive body collides with the light stationary body. Light is stationary body. Here the condition that M1 I'm considering as larger than M2 and M2 is 0. We all can draw like this kind of system. And then this equation tells you the V1. M1 is very large, so M1 minus M2, you can neglect this M2. M1 plus M2, also you can calculate this one. This part is 0, then you don't need this. So then this M1, M1 cancel, so it will be U. It remains at the same speed as the move. And here, M1 minus M2 minus M1, M1 is very large. So this part is 0. So in U1, U2 is 0, this part is 0. And here M1 divided by M1 plus M2 is negligible. So M1 divided by M1 also cancel. So then 2U. So it will be 2U1. So what's happening? V1 will be U1 and V2 will be 2U. So the moving body move with the same speed. Stationary lighter body moving is the twice the speed of the first body. Right? Twice the speed of the first body. So that's happen when this larger body, right, the larger one is collide with the light station. So these are the cases. So you can see them. If two masses are equal, the velocities are exchange. And if the stationary body collide with the the body is collide with the stationary body having the same mass, so then the body is moving body will stop and the body will move with the same speed. And when the light body collides with the large stationary body, so it will rebound with the same speed. The other body remains as stationary. And then in other case, the final case is very massive body collides with the stationary lighter body. So lighter body moving the twice the speed of the moving body, and the moving body does not change; it remain at the same speed. These are the key factors. Regarding this collision. So it's elastic collision. In your syllabus, you have the elastic collisions only. You don't have much in elastic collision. So these theories you need to. And during this kind of collision, this kind transfer of kinetic energy that's equals to the decrease in kinetic energy. Actually. Right, that is in inelastic collision we consider if there's a kinetic energy loss, So you can write next the kinetic energy was equals to the initial kinetic energy minus final kinetic energy of the system. Because if someone asks that what's happened to this kinetic energy loss, so they can convert it into heat. So some the other form of so mechanical energy of the convert to now the end of that's basic. So then we will discuss some questions regarding this. First question, right? Right on. A 8 kilogram ball, a 8 kilogram ball, moving with velocity 4 meters per second, moving with velocity 4 meters per second. 8 kilogram body moving with velocity 4 meters per second. 4 meters per second. Collides with 2 kilogram ball. Collides with 2 kilogram ball. Collides with 2 kilogram ball with the velocity 8 meters per second. It's moving with the velocity 2 kilogram ball moving with velocity 8 kilometers, 8 meters per second. 8 meters per second. 8 meters per second. I'm writing this in opposite direction. In opposite. Right. In opposite direction. Then if the collision be perfectly elastic, we call it elastic, right? The collision be elastic. The collision is elastic. What are the velocities? What are the velocities of balls after the collision? The velocities of balls after the collision. This is the before. So now you can find this using here conservation only. Moment in conservation. You can find the value and then send your answer. You can take a picture and send to the WhatsApp, or you can directly write on this Zoom chat ticket. Hari WhatsApp पर डाला. कोई भी बिनारी देखा तो ना थे ना. Velocity क्या है बात? නැත්නම් මම කියනවා මොකක්ද කියලා දෙනවා ඔයගොල්ලෝ ආන්සර් එක වන්න බලන්න ඒ වන්නේ ඉතින් શબ્ද නැති එක හරිය මම තේරෙන විදිහට ගාලා දාන්න Puta, me acabo de meter en internet. Realidad. Hacer actuar, hacer películas. Basic. Pegar com nuances. discuss करेंगे. Momentum conservation and the energy conservation. Energy means that's kinetic energy conservation is you can do this, right? But problem is uh, that's the simplification. The point. Okay, Bala. Only got you can apply the momentum conservation, then you can get the one equation, and then apply the kinetic energy is conserved. You know that the last equation before and after the collision, the kinetic energy is equal. Then you can get another equation, and by solving these two equations, you can simplify. So I will come to the question. Sam McKay question and the Sam can make a tag and term test exam gonna name one of exam make a good like maybe A or A level also. This kind of questions can. But exam make the over but the current only can get idea of couple. The current for the way I can't live it. The current exam make a very bar over in name of the current and how you to the current. Practice in the questions. අපි ඒක impatience දාලා කරන්න අපි දන්න ඔක්කොම ටික දාලා බලන්න. We can get the ID. කලින් පැත්තේ දෙන චොලක් දෙන්නේ කලින් පැත්තේ ඉතලා හිතන්නේ අවුට්ටෙන්. All right. अब बालों क्वेश्चन ठीक है बालों Alright. Now we can apply the linear momentum conservation in this direction. In this you can ID the linear momentum after the collision and before collision. Before collision. Because the linear momentum after. So in this direction, I'm applying this. This is 8 into 4 plus. And this direction is 2 kilogram. That's the velocity composite is -8, right? After the collision, this is 8 kilogram. 2 kilogram. By I'm taking in both sides the same direction. So we will come with the sign. proper sign we can get it right. And then for this equation, for the instance of our simplification, I'll take this 8p1 to this side and this part down. I'll take this 8p1 to this side, this part there. Then take 8 out and 4 minus v1. This is for the easiest of the simplification. 2 goes to this side and we take out and v2 minus this plus minus become plus to the journey. 2 plus 8 is first equation. And then the kinetic energy before collision that equals to kinetic energy after collision. So this is why we can use this elastic curve. Right? The elastic collision you can write this. That's the elastic curve. Writing this right. So kinetic energy is half 8 kilogram into 4 square plus half 2 kilogram into 8 square. That's not the reaction we have in this. Then half 8 v1 square half 2 into v2 square. Now the same thing, the half will cancel the half or in the half we cancel. And take this 8 down to the side and 2 kilogram onto the same mass goes to the same side. That's the easy difference in this kind of equation, which you can get as 4 square minus v1. And if 2 goes to the other side and 2 take out, then it is v2 square minus here 8 square. Second equation. Right. So to erase this figure, no need this. If you find this, you can get answers. Oh, is second equation divided by the first one. And here is 8 divided by 4 square minus v1 square. So divide by 8 and 4 minus v1. And this side is 2 times v2 square minus v2 square. And this 2 times v2 plus 8. In this 2 8 and 2 to cancel. Here 4 square minus v1 square is 4 minus v1 times 4 plus v1. So 4 minus v1 they cancel. And in this side also v2 minus 8 times v2 plus 8. That is the difference of 2 squares. So 1 is cancelled over here, the remaining one is 4 plus v1. Here the remaining one v2 minus 8. Right? Okay. Here you can write that v1 minus v2, that's equal to the, I'll take this 4 to this side. It's better v2 minus v1. v1 goes to there, 8 goes to this side is 2. This equation here. So then here you have the relationship between v1 and v2 also. So then for first equation you can get if this 2 cancel with this 8, it's 4 this side. So then v2 here, then goes to this side, it's v2 plus v1. And this 8 comes to this side, it is 4 into 4, 16, it's minus 8, so it's 8. First equation you can rearrange this 8 divided by 2, this 4 into 4, 4 into 4 16, this is 4, right? This plus 4 goes to the other side and 8 comes to this side. So 16 minus 8 is correct. Now this divide this 3 and 4 equation because the v1 and v2 you can find. These are the final, right? I did this, I brought them to the one. So then here you can write this 4 minus 3. V2 cancel. Here 4v1 plus v1, that is 5v1. And this 8 minus 12 is minus 4. So v1 equals minus 4 divided by 5. It is 0 for minus 0.8 meters per second. Minus means it's will the direction is not to this side. It is this side, so it's opposite the direction it has. And then substituting this value, this V2 you can write. Early equation you can say V2 equals to V1 plus 2. That is the minus 4, 5 plus 2. That means minus 7.3. These are the two results after the correction. 0.8 meters per second minus direction is this way, and 7.2 in the same direction you consider. I'll tell you again. Thank you. Is it clear or need to repeat it? Just talk or give an idea. Okay. That simplification and that if you use this as a star, if this and in the V1 star, it's very the terms come there. Because of that V1 and you substitute the V1 other equation and you substitute there. You can get the quadratic equation with V1 or V2. Then you have a simplified structure. That's also you can get the same answer, but it will wasting the time, right? So the way I simplify this, remember the same answers, take the one side and then take it as the difference of two squares. Then the easy way to simplify. That's why I'm when I'm simplifying this with the unknown values that we learn 1 and 2 like that. Also, I simplify in that way. So that is easier. If not, you are taking more time, and then in the examination also you can happen to waste your time. But this time waste you can do another question then with that time. Your sales on. Okay, then I'll give the another question because we need to discuss some of the question, but that part already theory part is already finished, right? So I'll share the question because when I read the question, it takes some time to write it down, right? So then I'll share the question with you. Documentation. Question still මේක ෂෙයා කරන්න. හරි. ඔයාලට ලියාගෙන හදන්න ඉතින්. Okay, let's take an example. Yes. You can write the question and try to give the answer. I don't know what. Upper then. Then okay, this is the question. I think now you can see the it clearly, right? So maybe after making a bigger cut pain number. Okay. This one. You can write the question first, right? You can take a screenshot and then they write it there and try to give the answer. Question again. ලියාගත්ත කමන්නේ ලියාගෙන අපිට ප්‍රශ්න දෙක I will give the 5 minutes to write it. ලියාගෙන ඉවර වෙච්ච ගමන් you can raise your hand then I can get the idea you finish it then I will discuss the question. 30 seconds of time. How is it? Anyway. Abi කොමලි වල ඉන්නේ. ඉහළ විතරක් කියලා මදි. එන්න ඔකල විතර කිව්වද? කියන්න බලන්න. If collision is elastic, then which of the cases are possible? Can I make it either before collision, the one is moving in the velocity v1, all the bodies have the same masses, right? So then 2 and 3 are stationary. Then after the collision, they given the 3 options there, right? The first one, they say that the v1 stationary, that's first one is stationary, and 2 and third one, so they stick together and moving with the half the velocity of the inclination. And the second option they given that the both first one and second one stationary, and third one moving with the velocity v. And then third option is given as all 3 bodies moving in v over 3, speed of v over 3. What? Hadi kohon padan. Mummy, karena me to do it. Over a jagat must not share. Right. So here. Line part, right? No. First case, please consider first case. Yes. And it's slow moving. Very low. Then let's see. We have checked that the momentum is conserved or find gain is conserved. The both should be satisfied. If it is elastic collision, only consider as the initial momentum. Right, this initial momentum of the system that is mass same into it. And then the final momentum of the system. So mass, it is the moment moving and into V over 2. So the momentum is conserved. initial momentum then equals to the final momentum is conserved, but it's not enough for this part, right? To satisfy this, then we can kinetic energy also comes. So then initial kinetic energy that is half m v star. Yeah, that's only one is here the final kinetic energy half is 2m and v over 2 star. So here it is to cancel it. M is power. So kinetic energy is not immediate kinetic energy not equal to final kinetic. Kinetic energy is not conserved. So that cannot be happen. The first case, it cannot be. You need to show it right. Here, the particularly then do second. And again, you can play. Third one. तर मेन है मेरी मेन बात है मैं आ गया स्टेशन लेके बजना या बीजिंग है ना मैं आना कर या गया है मेरे बदला मैं आया ना मैं आना कर तेरा मैं कर मेरे का तो वे ना तो बात initial thing we come it's not changed now you can check for the final one for the second case that's final momentum is nothing it's okay and final kinetic is half in this class that's also the energy is conserved and the momentum is conserved, so can be happened. The one is happened there, right? And then the third case, this is all are moving. So initial momentum, kinetic energy is this one. Finally, the momentum is so that's 3m. So masses moving in V over 3. In momentum is conserved. The kinetic energy half the 3 masses 3m and the V over 3 square. 1 3 cancel, so the energy is V over 6. So their kinetic energy is not conserved. Clear? When you write that, even the momentum conserved, the kinetic energy is not conserved, so this cannot be happened. And second, the first one is also cannot be happened. So only the second situation is. Okay. I thought you got it, right? Here I. Here I. And over here, none at the again, none in the. The next time appear. I get it. Viewing. You're on. Okay, I'm on the. There really love it. Ishi. You're on. Nero. I doubt that you know I'm again. Hi. Appealing, meaning I will another question. Second. This third example. You can write it down, and then in here you can neglect the friction. The gun is mounted on a railroad car, right? The mass of the car and gun and the good shell and the operator is 50 m. And is given 50 m, also 50 meters, right? Yeah, m is the mass of one shell. If the muzzle velocity of the shells is 200 meters per second, given that, and then asking what is the recoil speed of the car after the second shot. This one is little different question. You need to think more critical, right? Right? අපි බලමු. කාල ප්‍රශ්න නෑ කියලාද? රෝඩ් එකට ගන්න ඕනේ නෑ. යාගන්න. දැන් ඉවරට කරනවා. You see your hands. හරිද ප්‍රශ්නේ ලියන්න ඉවරද? මම කියන්නේ මම මේක බෝඩ් එකේ ගන්නවා. මේක ලියන්න. ඉවරයි නේද? තාම ලියන්නේ. තාම ලියන්නේ. All right. Stop the sharing, right? Okay, this they're given railroad, right? There's a gun, that's order is 40, 50 m. If it is 50 m, before it's fire the bullet, right? If the bullet is fired, the bullet is now come out. That bullet has mass and bullet means shell here. That's with the 300 meters per second. And then what happened is still recoil. The velocity is let's say v1. After the second shot, so now the second shot is moving. Now, initially they are at rest or things are right. But if first shot fired, it's still moving. If the second shot fired, then it's fired with respect to the gun. The gun is also now moving. So then with the second shots, you need to consider the relative velocity also, because you need to apply the momentum conservation. All the velocity should be considered with respect to the one frame. One frame means that's a with respect to ground is bigger, right? So I apply the momentum conservation for this. We can write this as initially 0. And now the velocity of the master is 200 momentum plus the recoiling velocity is a 49 mass is totally without this bullet and into I'm considering V1, so you can get the V1 and M cancel this minus 200 divided by 4. Minus it is minus because it's the opposite direction. Of the recoiling speed of the current. And then for the second polar is square, what happens? Let's see. When the second bullet is fired, this is the initial case. And then finally, it's velocity is 62. V1 already know. And then bullet is come out with 200 meters per second. And now it is 48 marks, right? Now, this bullet is fired with respect to this gun. So you need to find the velocity of the bullet with respect to the earth. So it's equal to velocity of bullet with respect to the gun plus velocity of gun with respect to the earth. Now, this is velocity of bullet with respect to the gun is 200 in this direction. And this is now this direction, right? V1 is backward. In this case, right, when the fire, I'm asking, this case, it's moving into velocity V1. V1 being at the unit here. It was say within per person the momentum change, right? You can say right. And this is moving to the other side. So it's 200. I'm considering the this side of 39. So then you can write simplifying this, we can say that 200 minus 200 is 49, which is 48 or 49 times 200. Consider this 48 or 49. And 1 over 49. King Alwin, share the 49. So then 48, share the 40. Clear? Okay. Then apply the momentum conservation in this section. Initial momentum means then initial momentum is the moment and without this bullet now I'm considering because make it following with the river make it moving backward. So it is minus mass is 49 in multiplied by V1. That should be equals to the final momentum is the momentum of this. So it is m into now not the 200 here, right? That's the speed of bullet with respect to the earth is this value. That is 8 over 49 into 200 plus the momentum of this body, that is 48 m into V2. V2 are considered in this direction. With the value it will be make it over, right? And then this minus 49 m will cancel. The V1 you can write V1 is 200 divided by 49. I'm considering it minus because already I consider minus. We don't need to put minus sign there, right? Make direction in which get a minus method I do not make it and not. Even after making become 49 meter only what we want to put minus. You have to think that this 49 and the mass cancel there. This 48, 49, 200 That's 48 V. Right, then V2 you can write. Mega mega tarara 48 करें मुक्तम मिलाएंगे with minus 200 divided by 48. Then 48 कर देंगे minus 200 divided by 48. तो मतलब ये minus and take the 200 out. 1 over 48 plus 1 over 48. Minus in we consider in this direction, that's which requires backward. That's all. This is the velocity of the gun after 2 bullets fired. Okay, I think it's clear. Yeah. Right. Then make the point figure. When you apply the momentum conservation, is better you need to apply all the velocities should consider with respect to one rate. Right. So this it is moving. The first bullet is fire is moving. Then you are when you fire the second bullet by moving bullet. So then you need to consider the speed with respect to the ground because that bullet is fired with respect to the heart or the vessel of the ground. Okay. There are more questions. We'll discuss later. I will go to the next game. Always this thing. Ini kita tunggu bahan bahan sebagai bahannya. Jadi mungkin hari kebenaran mana. Then next like okay, the rotation motion. This circular motion and rotation motion. Hi, rotational motion. Okay, you know already that there are different kinds of motion, the translational motion, the rotational motion, right? Rotational motion, translation. If body, right, and different particles of the body, they undergo the same displacement when they are moving, we can consider it as a translation. As example, say you have body like this, and when it's moving, it may be in the curvilinear or linear path. Yes, the body comes to this point. The path is followed by this thing. All the points of the body they have the same displacement. So it's a translator motion. And let's see if the body is here. We rotate about this point. And the particles in the body, when they're moving, they subtend the same angle for the axis of rotation. Same and all the particles same make the same angle, so then we call it the rotational motion. Even the angle is same, but we can see here this different particles, this particle A here, B here, C here. A travels larger distance than B. B is the model, and A is not moving. Actually, it's there. So in translative motion, all the particles they travel in the same distance, so same distance. But in rotating motion, they make the same angle, but the distances traveled are different. Okay, that's the difference between the rotational and translating motion. First, you write there. When different particles of the body, when different particles of the body different particles of the body undergo same angular displacement, undergo same angular displacement. The motion of the body is called rotatory motion. The motion of the body is called rotatory motion. What is called the rotatory motion? Here also right, but different particles of the body have different linear displacements. Different linear displacements. And linear displacement. Okay. Now you can draw this figure. Let me make it another pen. They're having the same angular displacement. All the particles have same angular displacement, but different linear. So this. this experiment then translative motion body translative motion translative motion translatory motion, right? Linear motion can right when different particles of a body undergo the same displacement, different when different particles of the body undergo same displacement, different particles of the body undergo same displacement. The motion of the body is called translatory motion. The motion of the body is called translatory motion or translatory motion, right? Then, your term stick about the just write angular displacement. Angular displacement. Right, yes, angular displacement. The particle moving from B to Q here. Speed to this weapon R is the angle between speed. This is the angle, right? So that is the angle is with by a line or by a particle about the axis or the point, right? So then you can call it the theta is the angular. When this particle making an angle above this point, it has a linear distance to travel all the place. We call it the arc length, which PQR. Okay, to write there first, write the angle. Angular displacement simply means that is the angle of rotation. Rotating angle. The angle through which a point or line, through which a point or line on straight line. Straight line through which a point or straight line has been rotated. Has been rotated in a specified sense, in a specified sense about a specified axis, about a specified axis, right? Specified axis is called angular displacement. is called angular displacement. It's called angular displacement. Then these are complete with zero, it's complete until start this point. So we can keep that to make an angle. So the angular displacement is a scalar quantity. Right? Under that also write there. It is under that, right? We can call this is right is the angle of movement of the body in a circular path, right? So, and also we can say it is a scalar quantity and scientific also we can write there. It is the angle of movement of a body in a circular path. Angle of movement of a body in a circular path. And the angular velocity, so the angular displacement and the angular displacement is a scalar quantity. Angular displacement is a scalar quantity. Draw this diagram. With angular displacement, then from diagram you can write. It's arc length divided by the radius. Arc length divided by the radius in SI system, you can write that. Arc length divided by the radius. Theta equals arc length is radius r. So then equation you can write to calculate angular displacement is equals r. R theta you can write. That is the relationship between this angular component and the linear component, right? Here, angular velocity theta that's equal to the linear distance is traveled is this. So that is the relationship between the angular displacement and the distance traveled. Then right, SI unit of angular displacement is what is SI unit? It's not degree, right? It is measuring the angle in the angular displacement, but its SI unit is radian. Not the degrees we are not using in this calculation. You need to convert it to radian. The right SI unit of angular displacement is SI unit of angular displacement is radian. Its symbol is R. Right. This radian. Right, it's radian. Then you need to know what is radian. What is the radian measure? The radian, one radian is defined as there is the angle subtended at the center of the vector by the arc length which equals to radius. Radius is equal arc length between angle subtended angle, we call it a 1 radian. So then write that. Write radian here, radian. Definition of the radian, right? Definition of radian. Then write there. A 1 radian is equivalent to the angle subtended at the center of a circle. Angle subtended at the center of the circle. Center of a circle by an arc equal to length of the radius. By an arc equal to length of the radius. Arc equal to length of the radius. Right. Okay. Right. You know this circumference length. What is the circumference length? So that circumference is equal to the right is circumference of the circle of radius r. That is equal to 2 pi. That's equals to 2 pi r. Then what is the angle subtended by the circumference? The circumference is 2 pi r divided by the radius. So it is 2 pi. It is 2 pi in radius. If pi we use mostly with radius. See the 2 pi radius. So we know that the total angle is 360 degrees. You can write that 360 equals 2 pi. So it means that that's 1 degree equals to the pi divided by 180 radians. So this value simplified, this value you can give the value it is 0.0175 almost, and this is 1 degree, that equals to this. If you want to convert the rate degrees into radian, you can use this formula. Okay. Finish. Well done. Tell me very much. Rapode. Ravidani pahala iwan. 30 iwan. Terms के लिए आगे हम basic topics. Okay, then write the angular velocity. Angular velocity. That's omega. Angle right. Angular velocity. Angular velocity is the rate of change of the angular displacement. So we can consider that at the that's angular displacement per unit time. Okay, right there, the angular displacement per unit time. Another type, the angular displacement per unit time. Angular displacement per unit time is the angular velocity. Is called the angular velocity. Angular displacement per unit time is called angular velocity. And even the angular displacement is scalar quantity. Angular velocity is a vector quantity. This is the polar vector actually. These kind of vectors are acted along axis of rotational axis. Their direction is along the axis, or into the axis or out of the axis, like that. It's not not like the other vectors. But it's a vector, you need to keep in mind. Right? Under that also, right? The angular velocity is a vector quantity. Angular velocity is a vector quantity. So we can write in terms of equation. Angular velocity is the angular displacement divided by the time to angular displacement divided by the time to. We can write this as something by equals delta theta divided by delta angular velocity. And also science rate. Angular displacement measured in radian, time is measured in second. The radians per second. Dimension. Dimension is t minus 1. And if there are no dimensions for radian, the time is t minus 1. Okay, is it a vector? Then we need to know how to get the direction of that. So by using the right hand corkscrew rule, you can use with the angular direction of the angular velocity. So it says that if the body is rotating to one direction, you can get your right hand and curve your these fingers, and then these fingers you can uh, change towards the direction of the rotation like that. So then the thumb will directed along the direction of the angular velocity. The body is moving to this direction, then thumb is directed. So then the angular velocity along the axis and in this side. And if the body is rotating to this side, so you need to place your right hand like this. To direction of rotation, you curve your other fingers. Then thumb will be directed towards the direction of the angular velocity. Clear? The direction of angular velocity is given by right hand of screw. Right hand of screw. Right. You will need to write the rule. Actually, I'm doing with the picture. Using the right hand, you see, finger, you can draw this also. of the line is not right. Okay. It's a rotating line. So it's rotated and previous selection is rotated. Now I think and even and those fingers are given the direction. So this angular velocity is a mark in the example of rotation. Another body it's like one. Let's see. Body is not good. If the body is rotating this direction, take your right hand, it's rotated to this direction, and then the angular velocity is along the axis. This always will be right. You can draw these two figures to get the direction. Angular velocity. Okay. Then write angular acceleration. After this point, we will stop, right? So next day we will discuss about the angular acceleration and other parts. Right? Next slide, angular acceleration. Angular acceleration. Okay, you can write there the angular acceleration, the rate of change of angular velocity angular velocity rate of change of angular velocity of a moving body or a rotating body or moving body at a moment at the moment is the angular acceleration is the angular acceleration at that moment. Angular acceleration at that moment. Alpha we use change. Write it as an equation. Alpha equals delta omega over delta t. Acceleration is also the vector quantity, right? Find this. The quantity. It's a quantity. Then write this SI unit. That's radians. First class dimension with t minus variance. This is dimension. Consider the body is moving like in this scenario, the body is starting from here, then because 0, its longitude is going at t time. And at this moment, let's say the angular velocity is omega 1. And after time t, this angular velocity is omega 2. It's moving like the theta. What is the axis of rotation? Right? In that case, which has the angular acceleration, let's say alpha. So that's alpha you can write in. The change in angular velocity, that is omega 1 to omega 2. So omega 2 minus omega 1. Divided by time gains. And that is the way you apply it to do calculations, right? Because change in angular velocity divided by its time. To write it down also, we have to use this for the calculations. So I'll give the example for that. And for example, I mean, yeah, just example. When a grinding wheel rotating at the speed of 20 rounds. 20 rounds, I mean, of the unit is 20 round. One round is 2 pi radians or 360 degrees. 20 rounds per second. 20 rounds per second. Right, when it is switch off, like when it is switch off, the wheel became still. Wheel became still. It's stopped actually. Wheel became still with the constant angular deceleration after 10 seconds. The constant angular deceleration after 10 seconds. After 10 seconds. Right? What is the angular deceleration of the wheel? What is the angular deceleration of the wheel? Here this omega we need to find 20 rounds per second. 20 rounds per second means that one round is equal to 2 pi radians. So this is now radians per second. We need to convert it to radians per second. It's better, right? So then this 45. I need to be substituted. And then alpha they are asking that is 0 final one, and initial is 45. So divide by the stake time 10 seconds. So then alpha equals minus 45 radians. It is minus because it's decelerate. In the calculation, the phi you need to, because if they are given the value for phi, you need to substitute the value. Maybe 3.14 multiplied by 4, then you can write this to this point. This task here. So we will stop the task at this point today, and then this class for tomorrow with this right. Okay. If you finish writing, you can leave. If not, if you have any questions, doubts, or anything you have asked, you can ask it. nothing to ask, then you finish the writing and everything, then you can leave. Okay, good night. Very question silent means nothing can be. Okay, good night, good afternoon. God bless. God bless. God bless. Okay, yeah, fine.